So we have a lot of things to tell you. So let's straight to the point. This presentation is about OpenTelemetry. So who is using already OpenTelemetry? Just a few. Okay, that's okay. That means you are in the right place, right? So OpenTelemetry, I will show you that is basically a project to help you to understand what's going on your code base. When you run an application, this is a kind of magic tools that can you explode the running time of your application to understand what's is. But in order to introduce the topics, we need to tell a little bit about observability. So what is observability? This is a kind of buzzword that, you know, a lot of people in the industry are using. Observability is basically the idea to understand a system from the outside. So I don't want to go inside to see, you know, the source code, whatever. I want to have some information coming from an existing application, a system, to measure, to understand what's going on. So, but if we just, you know, run an application, we see just the output, right? In a software, we just see the output of an application. We cannot introspect. We cannot, you know, understand really what's going inside the application. In order to give some information, we need to emit signals. What are signals? Are kind of information that give you an idea, for instance, how much time the application runs, how many bytes, and how much CPU usage, this kind of stuff. Something that is important to understand that is observability is not monitoring, are two different ideas. Monitors is basically tells you whether a system is working, so it's up, you know, it's off. It produces the output in this, you know, time, this kind of information. Observability lets you ask why it's not working. So it's more about let's understand what's going on, let's understand the performance, if we can improve something, or which kind of errors produce, how we can debug it, and so on. That's the idea. In observability, there are three pillars. There are logs, metrics, and traces. Everyone knows about logs, so it's something that we are very familiar with it, unfortunately, because it's very difficult to digest logs from a human perspective, right? It's just lines in a text file. That's a logs. So it can be millions of lines of code. So it's very, very tedious stuff. We have also metrics. Metrics are numbers, can represent CPU usage, RAM, whatever, and traces. That's the main goal of my presentation today, is to give you an introduction about traces, because OpenTelemetry, the majority of the idea around OpenTelemetry are based on traces. So OpenTelemetry is basically an open source project. It's vendor neutral, and it's about a set of tools that you can use to collect and exporting telemetry data, such as trace, metrics, and logs. It's a project of CNCF, the Cloud Native Computing Foundation, and it supports multiple vendors. Of course, also Elastic support 100% OpenTelemetry. And recently we joined the OpenTelemetry initiative, and we basically provide the Elastic Common Schema. That is a schema that we use it for the observability in the Elastic product as open source. So we are working together with OpenTelemetry to merge this schema into the OpenTelemetry official schema, because our idea is to use only OpenTelemetry for observe, using our products. I say that it's important that an application needs to send some signal, some information about the running. And these, again, are trace, metrics, and logs. What is a trace? A trace is a collection of information within a time frame. A trace can contain one or more span. So usually it can be, you can think about trace as a set of span. A span represents a unit of work of operation. For instance, we are calling a database. A span can be the execution of a SQL statement, right? Inside the trace of your application. So a single unit of operation. Each span contains some information, of course, because we are interested to extract as much possible information. The name of the span, the ID, so each span has a unique identifier, ID. The trace ID, because you have to collect basically the span into the main picture, so the main trace. You can have also a parent span ID, because you can have a span that contains subspan and so on. So you can have a hierarchy, basically, of span. Of course, you have the start and the end of the timestamp for the span. The context, so the information that you want to put inside the span. You can have attributes. Imagine that you are, the example that I give you for the SQL statement. You want to put the SQL statement inside the span, so can be easily, find when you are looking for the information. You can create events, links, status. The idea here is to give you the possibility to put all the information that you want inside a span. Of course, this information should be useful for debugging purposes. That's the idea. So if we want to represent graphically this idea of trace and span, we can think about a diagram where you have time, and this rectangular are basically the span. So imagine that this is a flow of execution. In this particular example, we have one span that is A, that contains subspan that is B, and B contains two subspan, C and D. And we have also another span that is A, represented with the time. Remember, each span has a start and stop timestamp. So we can easily aggregate this information with this visual UI. So basically, this is the trace, and these are the spans. Very simple. This is also called waterfall diagram. We have also metrics. As I mentioned earlier, metrics is basically measurement about a service, like CPU usage, memory consumption, and so on. But can be also something related to the business. Imagine that you are building an e-commerce application, for instance, and you want to have some metrics like the number of, products in the that you want to, order, right? That you put in your cart, or something different related to your business. You can inject this information inside a span, and this can be very useful because you can get, from a business point of view, not just for debugging purposes, but information that you can extract to understand, for instance, if your application is running well, if the traffic for a shopping cart, for instance, and so on. So very, very interesting. There are a lot of different metrics. This is the list of all the metrics that you can actually have in OpenTelemetry. You can have just counter, so some number that increase each time. You can have a synchronous counter, this idea of collecting information together, because you don't have basically a way to fix the number in a fixed time. You can have a strategy in your application that collects all this information. You can basically send in a batch style. You have also up-down counter, so a counter that can increase or decrease depending on your use cases. You have there is basically an asynchronous measurement, like, I don't know, in this exact time, I have this CPU usage, I have this memory allocation. And you can have also histogram, so basically collecting all together this information. And of course, we have log. Everyone knows about log, and maybe you are thinking why we need to collect also log, why OpenTelemetry cares about log. Just because we want to have one single point where we look at all the information and we can just have everything. We don't have to be crazy to find the file that contains the log in this exact time frame or whatever. Everything is in front of us, so we can easily navigate the data. That's the idea of basically OpenTelemetry. OpenTelemetry, the project, has a very nice sub-project that is the collector. So basically this is an agent that you can, more technically a service that you can run on your infrastructure that collects all the information coming from your application using the OpenTelemetry protocol. So it's the name collector is self-explained. The idea is basically that you can use this tool to collect all the information, and you can configure the collector to propagate this information to a specific backend. So it can be an open source project, can be a commercial one, whatever. And you can even have different exporter. So at the same time, you can export, I don't know, into Elastic APM, Elasticsearch, or you can export to a different vendor, or you can export to an open source, backend, whatever. Or your application, you can even build your, exporter. The default endpoint for the collector is the port 4317. Of course, we are using HTTP or gRPC. I will show you in a couple of slides some information about the protocol that OpenTelemetry is using, because of course this architecture works only if the environment is performant. Otherwise, if I put some signal in my application, this requires a lot of CPU time, a lot of HTTP connection. Of course, the impact on the application will be a big damage for us from a performance point of view. So everything should be, in fact, the majority of these tools are asynchronous. They try to use specific protocol, binary protocol, protobuffer, gRPC to optimize and minimize the information sent to the network. This specific project, the collector is written in Go, so it's very performant, and this is the link for the website. The collector is not just collecting data, but also processing data. So you can even configure it to say, look, I want to extract this information, I want to remove all the sensitive information like password or email, for instance. There are kind of regular expression, pre-defined type that you can use, and it basically removes, filter the input and the output. So this is very interesting. And of course, as I mentioned, you can have different backends. So if we see this diagram from left to right, on the left we have our application code that can be microservices, can be monolithic, whatever. You can have different options to emit signals from the application. You can have auto-instrumentation, and I will show you what that means. Using SDK, that means you have to change your application, putting some, start and stop function like logging, for instance, in the application. Open Collector can collect this information, but if you want, you can even just don't use the collector. You can send directly to the backend. So an application theoretically can send directly the OpenTelemetry signals to a backend system without passing the collector. Of course, as you can imagine, if your application is growing, if you're talking about microservices, the better solution is to use a collector, because you separate the flow. You can have a different networking. You can use the processor of the collector to remove some stuff, to filtering. So in a distributed environment, I strongly suggest to use the collector. If you just want to experiment with a simple application, you can even start without a collector. But when you go in production, you have different distributed services. The collector is the way to go, definitely. The collector is very simple to configure. It's just one file configuration in YAML. This is just an example. Here we are saying, okay, we can receive gRPC and HTTP communication from the OpenTelemetry application. And we are exporting into two different endpoints. So as you can see, the exporter, at the bottom, we have a list of all the endpoints. So that means the collector is collecting and sending to these two backends, because, I don't know, you have two separate backends, you want to split the information. So very, very simple. Okay, but let's talking about microservices, or more in general, because I don't really like the word microservice, to be honest. I prefer distributed architecture. So how we can observe a distributed application? That's not a simple question to answer, because, what means distributed architecture? Means that there are multiple applications, multiple services running in a completely separate environment, right? That's the goal of distributed architecture. That means some application can be written in PHP, some other in Java, even .NET, even a different operating system. And if the application needs to consume all the services and pass information from one services to another, for instance, this is kind of a nightmare to debug, right? How we can debug? Using log. So we need to open 10 files of log and try to understand how to connect this file. So it's crazy, right? A lot of people that start doing microservices, they underestimate this aspect. That is the critical one, because we need to test, we need to debug application. So how we can achieve this? Luckily, OpenTelemetry help us. So imagine that you have a giant application like this with a different connection between each other. How we can trace stuff like that? OpenTelemetry again help us on this, because the idea is the context propagation. So we need to find a way to pass information, this kind of ID, between multiple services. So imagine that you have a chain of HTTP call. So we need to find a way to connect all together this chain. And the idea is to have the context and the propagation. The context is the information that you want actually to exchange, and the propagation is the techniques that you use to propagate the information. For the propagation, we have a standard, actually many years ago, a W3C standard that is a trace context. So this is basically, if you read a specification that say, look, if you put in a specific header this information that is an ID, and you propagate this header to all the HTTP services, at the end you have a way to connect all the flow, and basically with OpenTelemetry you can extract and reorder all the information that represents in a graphical way. So that's the idea, very simple. You have an ID, you have to pass the ID between the HTTP call. So imagine that you have two services, service A and service B. You have a lot of stuff running on service A and the same on service B. At some point, service A needs to call service B. That's the idea. In this call, you pass the trace and the trace context as HTTP header. The header, there are a lot of specification, but the most important is the trace parent, that again is an header with an hexadecimal ID. That's it. If you pass this in all your services, you can basically collect the information. So you have a way to connect the dots. If you use a tool like, for instance, this is the one with the Elastic APM, automatically this information can be grouped using a graph. So imagine all these nodes, all this circle represents a specific service in your architecture. Automatically, this kind of system, because we have this trace ID, is able to, represent the information in a more, visual and useful way for us, for human. And we can actually understand the flow of the application. We can even discover something that we didn't consider in the architecture, because the amount of, if you put in a network and other nodes, the number of possible communication grows exponentially, right? This is kind of a mathematical results. And sometimes when you start doing this OpenTelemetry, you can even discover something that maybe can be optimized, so you have a better understanding of your application. That's the goal. Okay, there is a particular aspect of OpenTelemetry, very interesting, that names baggage. What is? It's basically a key value store that you can use to pass information across services. Because imagine that you want to propagate some information related to, I don't know, the customer ID of a HTTP call across multiple services, right? But you don't have this customer ID information in the HTTP request. For instance, there is no indication in the URL, no in a header, whatever. So you want a mechanism that enable you to pass this information across all your services. And that's the idea of baggage. Basically, it uses context propagation, the one that I mentioned earlier in the distributed. Let me give you an example. So I think it's you can understand better with an example. So imagine that you have two services, one for the checkout and one for the stock. So we are talking about a simple web API. The checkout is something like /account/123/order/456, where 1, 2, 3, and 5, 4, 5, 6 are the ID of the account and the order. So this is kind of a REST API. Inside the request of the checkout, there are a lot of process you have to validate, call database, and as you can see, there is a API over here. This API basically represents an HTTP call that I need to do application, for instance, to check the availability of the product in the stock. So you have, imagine, another endpoint that is /product/323/stock, so another service that give you the information, okay, this is product is present in our stock. Okay, so imagine that you want to propagate the account ID, so the 1, 2, 3 number here. I want to propagate this information to the stock service. I don't have anymore this 1, 2, 3, right? Because the URL is completely different. I don't have this ID. So I need to find a way to propagate this information. And the baggage is the solution. So basically, if I put everything in this baggage, the baggage will be propagated in the HTTP request for the stock. And on the stock, I can get back the baggage and get back the account ID. I don't know if it was clear enough, the example. Okay. I mentioned earlier the protocol, the OpenTelemetry protocol, OTLP. It's basically a protocol that explains how to pass this information across your architecture. For instance, from application to the collector to a backend system. You have two options here. You can use gRPC or HTTP. In both cases, you are using a protocol buffer schema to compress the information to send. Of course, gRPC more performant than HTTP. So if you have a very critical environment, I suggest you use gRPC. Again, you have to try to understand if your environment is okay also with HTTP. Especially at the beginning, if you want just to test, HTTP is more simple to set up, I would say. Okay, now this is phpday, so let's show some PHP code. How to use OpenTelemetry in PHP. By the way, this is really community oriented. So if you want to be involved in this project, you have just to go to the GitHub page of OpenTelemetry PHP, the one that I reported here, and you can start contributing. We have also every week, it's in Italy, it's Wednesday at 2 p.m. A public meeting, so you can join and discuss with the people that are involved in the project. So everything is very, very open. So you are more than welcome to contribute. Anyway, the PHP SDK contains the API interfaces for the hotel implementation. So if you are interested in support OpenTelemetry in a different project in PHP, you can just include this definition interfaces in your project, and you can implement your implementation of OpenTelemetry. If you want to use manual instrumentation, so imagine you have a PHP application, you want to add a couple of signal like trace, span in your application, you can use the library for manual instrumentation. It supports from 7.4 up. So we have also the auto instrumentation. That's very interesting. So instead of changing the code of your application, you are using a special extension that Hotel wrote for PHP that use the Xampp observer. This is a new API of PHP 8.0. So they introduce a way to basically intercept the execution of each function inside the engine of PHP. Very interesting. If you're not familiar with this, it's Xampp_observer, the new API they introduce. And you can use this API to basically inject your code at the runtime. So they use this new feature of PHP 8 to build this auto instrumentation. So basically, it's a PHP extension that you have to install in your PHP engine. And when you install it, you can say something like, okay, when a function of this class is executed, please, before the execution of the function, run this piece of code. And after the execution of this function, run this other piece of code. So you are basically instrumenting your application without changing the source code of your application. You basically need to execute this before as a preloading system in Composer. For instance, if you put files, I don't know if you know in autoload, if you have a special key that is files in Composer. If you put whatever you want there, each time the application is executed, so each time a Composer is executed, you have for free this auto-loading mechanism. That's the idea. And can be convenient because, of course, no one wants to change the source code application, right? The project contains also different exporters, so different plugin system to export data to a custom backend. So you can even think, okay, I want to write my custom exporter because I want to store this hotel information in MySQL for any reason, I don't know. You can just implement your exporter. And there are a lot of auto instrument modules, for instance, WordPress, Laravel, Symfony, already done. So you have just to use this project and you have a, for free, automatic instrumentation of your code using Hotel. That's very nice. And by the way, that's maybe something that if you are interested to contribute can be interesting, because if you see something that you are using, a library, whatever, in your daily job that is not in this list, you can write and start helping other people. At the moment, there is not 1.0 yet, but we are very close, especially for the trace. We have beta 10 at the moment. So we use a lot of beta and even alpha here. But again, a lot of people are working, and if you want to contribute, we can ship 1.0 sooner than later. Just some technical requirements for running this hotel PHP. Internally, they use HTTP factories, so the standard PSR 17. That means there is not some hidden HTTP client inside, so we just ask, please, which kind of HTTP client do you want to use? And as I mentioned, everything is asynchronous. Why is it asynchronous? Because we don't want to overload the application, right? So we want to send this information when the application is running. So long story short, you need to choose an HTTP client, asynchronous HTTP client. The one that we suggest is a Gazelle 7 adapter from PHP HTTP, but again, you can use whatever you want. From an environmental point of view of PHP, you need to install some extension here because you know, you need gRPC, you need zlib, you need protobuffer. So long story short, you have to install this extension if you want to be ready for all you know, the possibility supporting gRPC, HTTP, and so on. We even use some fiber-based context storage, so you need the FFI extension. That is a special extension start from PHP 7.4 that enables you basically to call every, you know, dynamic library .sol file, .ll file from PHP. So you basically can call any any C-level function directly from PHP. From a performance point of view, it's not the best in the world because there is this translation that should be done from you know, PHP to C and vice versa, but it's very, very powerful because you don't have to write an extension to, I don't know, use some library already in the community, right? So it's very, very interesting. If you never play with it, I suggest to have a look because it can open really to nice experiments. Okay, let's talk about the manual instrumentation. So imagine that I have an application. I don't want to use automatic instrumentation. I want just to change a little bit my application to adding this span, start, and end. How we can do this? We need to install the telemetry SDK. We need to choose an exporter. So where we want to export this data, we have to decide. We need to create a trace provider that is the main object to work with the OpenTelemetry, and we need to create at least a root span. That is the first span that you need to create. And inside you can have a subspan, matrix, logs, whatever. So this is the code. So basically the idea is to create this trace provider object, and in this example we are using the console span exporter. That means we are just output the output of this OpenTelemetry is the default standard output. So this is just for testing, just to understand what kind of you know, traffic, what kind of information OpenTelemetry will produce. And by the way, not surprising, the body of the HTTP is a JSON that contains some information. So I suggest to start with this little example, so you can understand which kind of you know, HTTP request the OpenTelemetry will build. And after the trace provider, we are just getting a name here, this IO OpenTelemetry contrib PHP as a tracer, so you have to choose a name. And as you can see in the root span, we are just creating, actually starting a span, again with a name. This example is root. You need to activate the span when you create it. And you, at the end, here, you imagine that you have your application with all the span, the metrics that you want to add. And you have to hand and detach. When is detached, basically the library collects all the information, the span, the metrics, the log, and generate the JSON and send it to the backend system. So this is the events of detach. So you have to consider this in your flow of your application, because that means in detach will be sent the HTTP to the collector or the backend. And you can leverage the fact that it's asynchronous. So my suggestion is don't put the touch at the end of your execution. You can even when you know that you have to send the information, that's the right moment. So you have to choose the best place according to your application. If you want to send, of course, to a collector or a backend, instead of the console, you have just to change the exporter. In this case, is OTLP HTTP transport. As you can see, this is the address. This is the default one. For 318 is the default port. For HTTP, this actually. For gRPC is 7, so it's 4317. And this is the header that requires the protocol. And that's it. To create a span, very simple. You get the tracer. So this $tracer is basically the object that you have to pass in your application. And you can start a span in this example. You have to activate. Remember, a span must be activated in order to start the span. And you can end and detach. The try and finally is the usual pattern used by OpenTelemetry, because of course, if you have exception, whatever, is the best pattern to manage all the possible cases. You can have a nested span, very simple. You have a parent here. We create a parent. We activate the span, the parent span, and we just create a child span inside the scope of the previous one. Very simple. You don't have to do crazy stuff. Automatically, the library is able to pass the ID and generate the ID for the span. If you want to add some metrics, you have a specific class here that is the method provider. You have to pass an exporting reader. And very simple, you can create, in this case, we are interested in storing the number of jobs enqueued. So you can add some numbers here, 2, -1, 2, and etc. So imagine that you have a flow in your application and you have something that each time updates the value. This can be interesting. And force flush at the end is the events that force the sending of the information. Log, we support PSR3, of course, so quite simple to use it. You have just to pass the logger to the OpenTelemetry library. That's it. So you have any logger that you want, I don't know, monologue, for instance, and you just pass with the logger holder with the setting. That's it. So very, very simple, the logging. Okay, let's discuss now the more interesting, I would say, the auto-instrumentation, because manual is okay. It's kind of library, but again, we need to change our code, right? And hopefully we don't want to. So you have to install this extension that I mentioned. We provide Pickle, even Docker, so you can choose the best solution for you. And when you have this, basically execution, what you have to do is writing hook, basically. Hook means, okay, I want to observe the execution of a particular function. In this case is the run for the demo class. So you have to specify, okay, this is the class that I want to observe, and this is the function. Before and after the execution of this run function, you can write your pre and post function. So basically the events that you want to execute. As you can see here, these are anonymous function, and we propagate the tracer inside the execution. So imagine that in the pre function you want to have you want to create a span. This is how you can do it. So basically you have a static variable here that is instrumentation. We have take this from a cached system, basically, that give you the contents of the instrumentation. And as I show you in the previous example, you have just to take the tracer and start the span. That's it. This is very simple and minimum code. Of course, you can add whatever you want here. And this is the post. So the post is a function where you have a couple of parameters passed. You have a tracer, of course, and here we are just detaching the scope, and you can even do nice stuff like exception. So imagine that the function that you executed, the run, throw an exception, right? We want to get also this information using the post. So we have here the exception that is passed to the anonymous function. And if exception, you can just record the exception, putting a status, whatever. So it's very, very powerful. Okay, so I put some references here talking about OpenTelemetry with our stack Elastic, and I want to mention this. I mentioned earlier, we recently joined the OpenTelemetry initiative as Elastic, and we provide this Elastic common schema. It's a way to extend the hotel OpenTelemetry schema with more powerful feature. So even if you are interested, if you are not, you don't want to contribute from a PHP level point of view, but you are more interested in, kind of architectural aspect, you can even join the project and discussing about this new schema. Okay, that's it. Thank you very much.
Thank you, Enrico. Any questions? There is one. There is two.
I'm just wondering in how mature the whole stack is. Is this something that is already ready to be seriously used?
As I mentioned, is in beta and alpha, so you can start using it, but officially we need to wait the 1.0.0 to be in a good shape. But we are very close for the trace. So if you are interested just in tracing, I think in a couple of months we can have it the 1.0 ready.
Okay, I have a question about the nested span example you showed us before. Yes. In the try finally syntax you shown, you open the nested span. Okay, so what happens when in the do stuff part you actually throw an exception? The child span info are gonna be lost, or it's gonna be ended automatically when the parent span?
No, you need to. This example does not have the the catch basically. So you need to catch the exception, and you need to end detach. Otherwise, you will have a not ending span. That the protocol OpenTelemetry recognize this aspect as and automatically end the span for you. Basically, that's the idea. But it's better to always catch the exception.
Okay, thank you.
Yeah.
Any more questions?
You mentioned logging before, and I wonder if that comes automatically with structured logging, or if that is still a...
Sorry, I didn't understand the question.
You mentioned logging before, and
yes.
that would be just a string that you have in your log
yes.
file.
Yes.
Now you mentioned logging would be done in that product, and is it automatically coming with structured logging and giving you that power? Because I believe there's the real...
Yeah, so basically the idea is just to get the logs that produce the logger, your logger, and putting in an OpenTelemetry compliant format. That's it. So you have just one way to introspect the log, the span, the metrics all together. So you can, of course, there is not kind of, metrics, logs, and the span are not really closed. But when you have the span, and at the same time you know that this span produced in the same time frame, these 3 logs, you can easily, check. And I think it's very, very powerful from this point of view.
Thank you. Any more questions? Okay, I think, thank you very much, Enrico.
Thank you. Thank
Big
you.
round of applause.